on to objective 2, which is typing these different expressions. The key thing with these expressions, I know they look kind of weird, but it's when you take log base a of base a to the x, and a raised to log a of the x, like what do we do with them? They're actually the easiest expressions to evaluate. If you're taking the log of the same base that you have, they're inverse operations. Remember, how do you undo rooting, square rooting? You square. How do you do undo addition? You subtract. How do you undo exponents? You do logs, okay? So look at this rule. I know it looks kind of weird, but the rule says for any base a and any real number x, when you take log base a of a raised to some power, the log base a and your base a kind of cancel out, and you're just left with x, okay? Where it comes from is, think about what we learned yesterday about writing it as an exponential form, right? So what's the base of my log? A. What exponent am I going to raise it to? X, and it equals the opposite side. A to the x equals a to the x, right? So just kind of keep in mind that bases cancel out. So whether it's a base for your log or a base for your exponent, they'll cancel each other out, and you're just kind of left with that exponent. They're inverse operations, all right? So, like I said, it's a little bit easier than what we just got done doing down here. So look at, Corey's already done, and I thought you were done. I thought you did all three. I'm like, whoa! So what were you saying? It's just A, exactly. So we're taking log base A of A. So those are going to be inverse operations, and what is it going to leave us with? Just the exponent, 8. It's what you guys did on your worksheet yesterday before you knew this rule, right? You were calling this y or x, right? And you're saying a to the y equals a to the 8. What does my exponent need to be to equal 8? You know what I mean? You were doing that yesterday, but now you know the rule. All right, so what is the base? Yep, I was going to say, what is the base of natural log? E. So you're taking log base e of e, so it just leaves you with the exponent, negative t.
I don't like it.
What is the base of this log when it just says log?
10.
10, right? So log base 10 of 10, they're undoing each other, and you're just left with 3k. Hooray! And guess what? The back is exactly like that, but it's just the opposite. So if you raise a base to the logarithmic power, it's the same idea. As long as the bases are the same, they're going to cancel out. So notice here, we're raising a to a log base a power. We're raising a to a log base a power, so they're just going to cancel each other out, and what you're taking the log of is going to be your remainder. So let's jump to number A real quick, or letter A real quick. Notice we're taking log base 4. So these are going to cancel out, and what are you just left with?
K.
K.
I did them.
Right? Natural log, what's his base? E. So you're raising e to the natural log power. They're going to cancel out, and you're left with? 5. And then log is just log base 10. So 10 and log base 10 are canceling out to... And again, where it's coming from is just when you go backwards, right? You say, okay, what's the exponent? Log base a of x equals log, what's the base a of the opposite side? So it ends up equaling each other.
Fun.